Hello and welcome to Beamer, folks.
I thought it was about time I introduced you to another takeaway box creation of mine, and this is a Nightlight. I consider it Nightlight Plus because it offers one or two features. This has been running in our home for about the last 4 years, and we have elderly people around the home, and it needed one or two additional features that a basic Nightlight doesn't offer. Also, there is something I've explored within this unit that I found interesting, and that is that it doesn't use the usual light-dependent resistive light sensoring system. It uses a photodiode, and it switches off the LEDs before a measure is taken of the light level. This gets around the problem of feedback with normal Nightlight units, in that if, say for example, it's nighttime, if the threshold is achieved, the lights on a conventional Nightlight system will fire up. But the problem is, by firing up the lights on itself, the sensor, the LDR sensor, now picks up the light that itself is producing, which causes oscillatory feedback, and this can be quite bad. And I've tested a couple of them, and I've found them all to oscillate at certain low frequencies under certain circumstances. So I tried to think of a system which would get around that problem, and the one I came up with was to switch off the Nightlight completely for a fraction of a second, and during the off time, which is hardly perceptible to the human eye, to then, within that period, to make a sample of the light level. So in a sense it gets a true ambient light level value. I'll start by running through the basic features. Okay, so what we have here is 3 T10, these are car bulbs. These are not the CAN bus type LED bulb assemblies. They are without, I think it's 120 ohm that bridges the LED for CAN bus. These do not have that feature. That would be just a waste of energy. But the ones I'm using here are actually quite bright. They are 13 LED assemblies per LED bulb, and of course I've got 3 of them. Adequate for, say for example, hall lighting, particularly on full blast, but overnight you don't really want them running at full blast. The reason why there is a Nightlight is that some people like the hall dark because they can't sleep through it, and other people like it's a little light because it helps them sleep. So there's a conflict here, and the Nightlight serves that purpose. But I'll go on to the next bit. The next bit here is the brilliance control. Yes, this Nightlight can be adjusted. You can adjust the brilliance. There is a light dark or dark light threshold. This can adjust the position, the actual threshold point at which the Nightlight fires up the LED bulbs. Found to be quite useful. The next control here is a push button. It's a multifunction push button. One is that you push the button for full brilliance. So for example, you wanted to go to the bathroom, you just come along and push the button, and the LEDs will light up for a fixed period and automatically turn off after that fixed period. The next feature of this button is a random light effect. I kind of added that because it was fun to do, but actually in some ways it can be a little useful, having these LEDs switch on and off at random times at random brilliances, simply because it kind of looks as though there's somebody in the house. And you can buy these units on the marketplace that actually are dedicated to that feature. But primarily I did it because it was a bit of fun to do it, and I could actually do it. But it kind of serves a small, secondary purpose. At the front here is the LED sensor, the photodiode sensor, I should say. The assembly is made out of an electronic PC board support pillar, which has been drilled out to accommodate the photodiode. The photodiode is kept within a effectively dark space, and there are reasons for that, and I'll go into that later. And this is the point I found quite interesting. Going round to this side, we have the mains, the power supply input socket, and it runs on 15 volts at a maximum just under an amp, about 3/4 of an amp on full power. So you need an adapter that will power this, and I use a 15 volt 1.2 amp Scalextric power adapter, and I have to add a caveat of warning here: do not buy cheap adapters. They can be fatal. It's far better to spend a little bit more money and get a power supply wall wart from a reputable source. Very important that I don't tolerate power adapters from just anybody. You can buy them very cheaply from abroad. It's just not worth it. You don't know how they're made. If you open them up, you can condemn most of them. So it's good to put a little bit of effort into finding a power. I mean, you may have a Scalextric power adapter which you can redeploy for this. I've got a drawer full of power adapters, and I managed to find one with 15 volts over with a output capacity of 1.2 amps to drive this. I didn't have to buy it. So what have we got here? I think that's more or less the outline. I built this actually onto a printed circuit board. It's powered by an Atini 85 8-pin chip. I was quite proud of myself to fit all the software into such a small chip to drive all of this. It is quite complex, the software, to drive it, surprisingly so. A lot of mathematics involved, but I quite enjoyed doing that. But I went through a number of versions before I got a satisfactory result. One of the other versions of this software I made had this push button where you push to turn the lights. It's a manual operation as opposed to auto. You push the button to power up the LEDs on full brilliance, and then you push the button again to turn them off. I didn't find that quite as useful as an auto turn off. Now, having gone through the basic features of my Nightlight, I thought I would power it up and show you how it works. So I've got the terminal here from the power adapter, and I'll plug it in. There we go. It's always I've got a tripod, and it's always a problem working around the tripod. I tend to knock and thump things, so let's just power it up. And there we are. Now, as you can see, it's lit up already as soon as you turned on. If I adjust the brilliance control, you can see that I can vary the brilliance. And the reason why that feature is offered is that during the daytime, of course, the unit won't fire up the LEDs because it's not dark enough. So I incorporated a facility where for a short period of time, as soon as you turn it on, you can adjust. It gives you the option to adjust the brilliance that you would like at the night time. When the LEDs are powered up at night, of course, you can also adjust the brilliance. But obviously if it's daytime and you power it up, you've no idea how bright it's going to be at night. So that's that feature. You can see that there is the ubiquitous flashing blue LED here on the board, and that is sampling the light at about 3 times a second. So during the daytime, of course, you don't really see anything other than that single flashing blue LED, and that is indicating that it is actually sampling. And the next feature I do is, what shall I do? Push the button, I think. Let's do that. So if I push this button, now I think it'd be better if I actually turned off the studio lights here, so that we get it'll go dark for a second, and there you are. And because it's gone dark and I've had the threshold set at about 2 o'clock, it means that the LEDs have come on. It thinks it's nighttime. Now let me just adjust the brilliance to show that you can, during the night, if you wish to, you can adjust the brilliance of those LEDs. But if you have them very low, this nightlight doesn't act as a very good hall light. So now if I push the button here, you should see it come up to full brilliance. And there we are. And that is actually quite bright. It probably doesn't come over on the camera, but it's enough to light up one area of a hall. It doesn't obviously cast light down the whole hall, but if you have this placed in the middle of the hallway, it gives adequate light to go and do what you need to do. So that's it. It will run now for about, I think it's about 10 minutes I've set this to, and we won't do that now. What I'll do is just unplug it so that I effectively reset the CPU, or microcontroller as I should call it. Now plug it back in, and there you are. It goes back into the giving you an opportunity to adjust the brilliance option, and that will switch off. Let me adjust the threshold down so that we've got, and I've set it to about, it's about 9 o'clock, which means that the room has to get pretty dark before it comes on. Now let me show you the other feature, and that is if I push the button and keep my finger on the button, it should do this random LED dance thing. The main PCB LED, the blue LED, is now at a constant. And there you are. And that indefinitely does this random stuff. It randomizes both the change when the state changes and the brilliance of the LEDs. So it's a sort of a dual random feature. I just unplugged that now, and let's go back into normal mode. I think I could have turned that off via the push button. I can't remember now. It's 4 years ago since I built this. Right, what I was going to show is let that go through its little initial state, and there we go. Now if I go to full brilliance, something I'll show you, if I go to full brilliance, there the blue LED phases in and out to indicate that it's actually in that mode, full brilliance mode. Excuse me, that's what I thought I'd show you. Okay, so let me unplug that. Let me switch back on the studio light. There we are. And we're back onto there. Okay.
This is Beamer signing out for now.